Yeah, let me just record this for the purpose of those who might be coming later. So I was saying, today we're going to cover a concept that is really going to be of help if you're looking forward to develop smart, or rather develop smart contracts that are going to interact with other smart contracts. Now, think of it like if you're a Web2 developer in the house, I know this is going to make some sense to you. Let's say there's an API. I'll call it weather API, okay? Then this API is sitting on a server somewhere, and it's a whole system on its own, okay? So basically, they may have endpoints to the API. Maybe you could be requesting some weather data for a particular location. So you're required to provide certain, or rather describe the location you want the data for, and then they respond by data for that particular, by the weather data for that particular location. Now you can use this data within your API. So in this case, we are having two different web systems that are interacting through web APIs. Now, the same thing can be achieved on near blockchain through what we call cross-contract calls. Now, if there's a smart contract on the near blockchain that your smart contract wants to interact with, in this case, I know we'll be looking at this, but then let me just introduce the concept right now. We'll be looking at what we call fungible tokens and non-fungible tokens in our coming classes. And these concepts, or rather these smart contracts, will make use of cross-contract calls. In this case, you will be invoking a function from a different smart contract, and all the operations will be done right there. Then you'll just be waiting for the response. Sorry. Then that response will be returned back to you, and then you can do you can process it further within your smart contract. So in this case, we are having two smart contracts within the near blockchain communicating. So that is where the concept of cross-contract calls comes in. So this is very, very important, very critical if you're looking forward to advance in these blockchain Web3 development, software development. So that is it. If you are here in our previous class, maybe I'll just remind you to you should have started actually working on your project, and if you've not, please finish up ideating on your project and start working on them as soon as possible. We need you guys to be certified. So let's do this. So I'm just going to reshare my screen, basically reshare everything. Okay. Oh, Timothy, if you are actually, if you guys want to talk, you can just raise your hand. Then I'll give you a chance to air your views. Timothy, you now have, you can now unmute. Did you have any question?
Okay, thank you. No, not yet.
Okay, thank you. Awesome. So if you have any question, guys, you can just raise your hand. I'll get back to you, or I'll give you the opportunity to talk. So let me just reshare my screen. I'll share everything. So we're going to work from this. I hope you guys can see my screen. Maybe if not, you can just put it in the chat. I'll be able to see. So today we're going to work. From this folder, cross-contract calls. Never mind this folder I was working on earlier. So I just launched a terminal from that particular folder or directory, and I'm having two windows within my terminals. So we're going to create two different smart contracts within these two windows. Let me call them two different smart contract projects. So we're going to do one in assembly script, then we're going to do the other one in Rust, because I posted this in the group, and I saw that only one vote made the difference. So sort of people wanted to know how to do this in assembly script and Rust. So I just decided to go with the two. So in the first window, we're going to create a near app assembly script, smart contract project. We're going to call it cross contract call assembly script. So that is the basic name we're going to give it, and then I'm going to press on enter. Then I'll move on to the next window, and I'll just run the same command, near create near, sorry, npx create near app, sorry guys, dash contract. So in this case, we're going to use Rust for our contract, and we're going to call this cross contract called RS. So those are the two projects you're going to work with. So we'll just wait for this to sort of build, install, set up the project, and then we'll be coming back right there. So as those proceeds, maybe we can still talk about the cross contract calls. I was saying, I was talking about actually the fungible tokens, and I'd really advise all of us who are here to really read on fungible tokens even before we tackle them in our coming sessions, because there are some concepts I'd really prefer if you guys would try and grasp before the session. That would make understanding these concepts quite easier. Now, fungible tokens have what we call standards, and these standards have been implemented in Rust. Okay, all the standards have been noted down. Maybe if I can just fire up my browser and awesome, right there. So if you open, maybe I can share this in the chat for all of us to have a look at these. If you just open that link, it will bring you to this page, and it's basically talking about, now under standards, it's actually the last drop down on your sidebar. It's talking about standards of fungible tokens, non-fungible tokens, storage management, and all that. So I'd really love or advise you guys if you could just go through all these standards. It's basically talking about the standards of a fungible token and all that, so that when you come in as coming sessions, it will be easier for us to go through this. Now, if you read through fungible token, you realize that there's a function within your fungible token, and like I said, these standards are implemented in Rust and not assembly script. So you can be showing up. Coming classes will be focusing mainly on the Rust programming language. Now, these standards have been provided as a library, a Rust library for you to develop with. So some of these functions have been already implemented within that particular standard, and all you need to do is to implement and sort of structure from there. So there's a function called in fungible token transfer call. So transfer call basically transfers token to the receiver wallet address. In this case, the receiver wallet address is another smart contract. So in this case, it's basically transferring tokens from whoever is sending the tokens to that particular smart contract. Then after that, a cross contract call is going to be fired immediately during the processing of that particular transaction back to the contract that sort of called or rather invoked that function on the fungible token contract. So in order to understand what really goes on with the cross contract call and all that, it will be very, very necessary if you guys are going to pay keen attention in this session. And if you have any question, just feel free to raise them up. Now, our project setup is done. So I'll just CD into them. So in the first window, I just changed my directory into cross contract call AS. Then this one, we're gonna go to rs. Okay, then I just clear. So from there, I'll fire them all. Oh, sorry. I'm just going to work with the contract folder. So right here, if I list all the files within this directory, you realize that we have a directory called contract. So that is where I'm gonna work from. So it's just good if I also work from that from my terminal. So I'll do the same from this end as well, and then clear the window. So I'll now fire these in my IDE and these as well in my IDE. Let's see what that brings on board. Okay, so here we go. So we have two projects right here. So we have two projects right here with us. The first one is assembly script project, and the second one is smart contract project in Rust. So we're basically going to work from these two folders. So I'll begin with the Rust. I'll just cd, open lib.rs file. Then I'll just expand that over here as well. Then right here, you realize there's some boilerplate code we've been given right here. So we're just going to use them, but I'm just going to do some few changes in them. Like we don't need the record instance variable. So we can just return for empty, sorry, self. Then inside here, we're also going to come up with our own method. So we can just delete all that. Then we're not going to work with the test. So right here, I can basically clear everything. And let me clear everything up to that point. Then we're going to create a method that we're going to call from the assembly script smart contract. Okay, so this method is going to really be simple. So we're gonna call this hello world. Okay, then Rust things right there. This method is going to return a string. So it's going to return a string. And the string is going to be hello world from, let's call it hello world from Rust smart contract, just to bring in some difference or differentiate it from the assembly script smart contract. So we're basically going to turn this to string. Okay. This should be that, not what I wrote. Yeah, so that's this is Rust method. I hope you guys can see this. I don't know if my font is quite of good size. So I've just impressed it. So that is the method. It's a hello world. It's basically returning a string, hello world from Rust smart contract. Okay, so that is it. I just saved it. Then I'm going to, guys, I'm going to work with the script. So I'm just going to write some scripts here that are going to help me with the deployment and building of all these. Okay, so awesome. So let me just get these from. So we're going to have a build.sh. Then you're going to have a deploy.sh. And you're going to have a call.sh script files. Then we can remember this. Okay. Let me just confirm this from there, there. So I'm just pulling these. This is the command you're going to use to build a smart contract in Rust. Then after building, if all goes well, we're going to deploy. Now to deploy, we're going to use the wallet address we created in our previous classes or in our previous sessions, that is last week. So the very first thing I'm going to do is to delete an account if it exists. So I'm going to do near delete. In this case, I'll be using an account called XSS rs, right, .sa.cohort2.testnet. I hope that this should be a hyphen. So this is the wallet address we created in our previous class. Then I'm creating a sub account. So this is going to be a sub account of this particular wallet. So master account is going to be this right here. Awesome. So after that, after deleting, I want to recreate or rather create this account. So I'm going to do near create account. In this case, we're creating this particular account. So we just put it right there. And I don't think we need this one right here. So we can put it over there and we can just get rid of these. So that's how it should be. So I hope I'm not losing anyone, please, guys. So yeah, that is it. Then after that, after recreating that account, we're basically going to deploy. So we do near deploy. And in this case, we are deploying to this account we just created. So this sub account we just created right there. And whatever we are deploying is a WASM file, WebAssembly file. In this case, it is under the directory where we copied it to right here. So this one will be under res slash. I think it should be release, right? But we're going to confirm this once we build up everything. Then I'm just going, by changing this name in the cargo.toml file, that will basically determine the name of the WebAssembly bytecode file that is going to be created or built, what is basically going to be named. So I'm going to call this X cross contract called RS. Then I'll just copy that, save and copy, then paste it. Oh, sorry. Paste it right there. No, what did I do? XCC rs.wasm file. Yeah, so that should be able to help us do all that. Then in call, let me also carry this with me right here. In call, we basically are going to do near call. This is a view function actually, so we're going to do near view. In this case, we are viewing a smart contract function deployed in this particular wallet address. So I'm just going to copy that right there. Then the function we're going to call is hello world. Okay. In this case, it doesn't need any argument, so we're just going to leave that like that. Then I'm going to get back to my terminal. Remember, we are working from this folder. These are Rust contract project. So I'm just going to first of all give some rights to my script files to run. Now to do that, I'm gonna run this simple script or command, sorry. So that should be able to do the magic. And I simply clear, and now we can fire up our first script. So that should be able to help us build the smart contract. If there's an error, it should be able to show us right here. If there's none, then all is going to be successful. So let's just wait and see what that is going to get us back to. It's taking quite long, man. So as that builds, you should actually create a folder. Right here, you should avail the WebAssembly bytecode within the res folder or the resource folder after building. So let's hope that is going to be successful. Now, maybe as that builds, because you also don't have time, I'll be talking about the cross-contract calls in Rust. Now, to implement a cross-contract call in Rust, we're going to need to create, now there are some macros that have been availed in here that are going to help us sort of set this up. Now, the first macro is basically going to help us, where is that? So let's just do it right here. So the first one is going to help us. Yeah, our build is, I can see our build is also ready. So, okay. Maybe I can just go ahead and deploy this. So let's see. Now, these are warnings. There are some things we've imported, but then we've not made use of them. So that's why you can see the warnings. However, everything was successful because there's no sign of any error. So we can just go ahead and deploy this. And remember, the account you're going to delete initially right here is not yet created. So you can expect some error right there. But then after doing this again, or if we redo this, all should just run well. So let's go ahead and try that out. Yeah, so that is the error I was talking about, because it was trying to delete an account that doesn't exist yet. So, okay. Now there was another error. What was that? Was created. Oh, okay. I guess our path, you realize it's under a resource folder. Then I think I just gave a wrong path right there. So I'll just correct that and maybe redo this again. So I'll just clear my terminal and run the deploy script again. So this time round, realize the error is gone. While deleting, it's now creating and saving the credentials within my machine. For the cross-contract RS sub-account, and again, there's an error. Now, what's happening? No such file. Am I getting something wrong here? Should be under this right here. Then, oh, sorry. These guys are using underscore. So instead of repeating the deletion and creation, I'll just comment those out and just go ahead and deploy these guys for us to also save on time. You can see time is really running out. So these are some of the reasons you're advised to do your projects in assembly script, because Rust really has a lot of issues. But we did that, so deployment was successful. Awesome. I can just go ahead and comment all that. So let's go ahead and call our function from the smart contract now and see what we get back. Awesome. So that is our function, hello world from smart contract, from Rust smart contract, sorry. So that has been called from blockchain, the testnet network. So I'll just clear that out. So now, now that we have our project in Rust and deployed under this particular account, we're going to call it from a smart contract we're going to write, but in assembly script. Okay, so those of us who are here and really want to see how this is done in assembly script, this is your chance now. So I'll simply, I don't know if I can, let me just highlight this guy first. Awesome. I hope you can still see my screen. I really hope you can still see my screen. So right here, I'm in assembly script project. And over here, I'm going to work within the index.ts file. So that is the entry file in our assembly script project. So over here, I'm simply going to delete everything. We're going to start this from scratch. So in the first place, we're going to need a class, or rather to work from a class. So I'm simply going to export a class. In this case, I'm going to call it contract, but you can call it anything as long as it's within our entry file. I'm going to use some near decorator right there, near engine. I hope you guys can remember the need for that. Then within this, I'm going to write a function that is basically going to call the method we deployed in our Rust project. So in this case, I'm going to do cross contract call Rust. Okay. I'm running short of words of names to use. So I just call it Rust. We're going to return void in this case. Now, we also need to define some few constants up here, guys. For those of us who are in assembly script, the first one is going to be the gas you're going to use for the cross contract call. So in this case, the gas, and maybe I just never showed us there. I shouldn't have cleared this out yet. Maybe I can just redo that. There's something I want to show you right there, but you can proceed as that runs. So in this case, we're going to use, let me not guess this. Let me just show us. Okay, it's done. It never gave us any receipt. So, okay, let's use 7 teragas. 7 teragas is basically 7 followed by 12 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that is 7 teragas units of gas you're going to use. The other one is going to be deposit. So if you're going to use any deposit is basically any attached tokens to your smart contract call. So in this case, we're not going to attach anything or any token to that. Then our cross contract, let me call this ID. Let me just call this ID. So this is basically the address that we are going to call this method on. So like the other smart contracts address. So in this case, we're using this address where we deployed our smart contract. In this case, this is the address. I'll just copy it as it is and bring it right inside here. So that is the wallet address where we deployed the smart contract we're going to call from this smart contract we're writing now. Then I'll go ahead and now initialize the cross contract call, and this is how we do it. You do contract promise. So that is basically going to bring in this object from near SDKAS package. And then we're going to create And right here, you realize it requires the contract name, what we've called in this case, the cross contract ID. Then it's also going to require the method name. In this case, the method name is hello world. It should be provided as a string. So that is the method that we wrote in our Rust smart contract. Then it is also going to require the arguments. Now, in this case, our method does not require any arguments. So we just give an empty object. And we need to explicitly say here that our argument is taking the object data type. Then we're going to pass in the gas we're going to use for this particular cross contract call, and any attached attached tokens, if any, that is attached deposit. So up to that point, that should be able to sort of call that particular method in the contract we deployed. Then I'm basically going to do promise dot return as a result. So in this case, we should be able to see the result of the method hello world that is going to be called from the Rust smart contract we just deployed. Now, up to this point, I think this is also done. So I'll just, we're not going to write any test. So I'll just do a folder here, scripts. And like, if you can recall, these are basically going to help me do things fast. So we're going to have a build script. We're going to have a deploy script. We're going to have a call script. Then to save time, I'm basically going to copy the contents from what I wrote right here, Control C. Now, unfortunately, we don't need this. So this is quite easy. We're just gonna do yarn build. That should work for us. Then deploy. I'm just gonna bring all that over here as well. And right here, we're going to make some few changes just to the sub accounts we are creating. So in this case, we are doing a cross contract call assembly script. So I'll basically make the change right here so that we have different sub accounts. Awesome. So we're first deleting that. And this is the beneficiary account. We're creating this. And this is the master account. We're deploying to this account. And our file is going to be right here, build /release. This should be the name of our file. So I'll just make that change within the package.json file as well, so that we don't have any issues with this particular while building, sorry. So I just changed to the assembly script smart contract terminal. I'm going to clear everything right here. Then I'm going to first give permission to my scripts to run. That is how I do it. That did the magic. Then I'm basically going to do scripts. So first of all, I'm going to build. Okay. So that should be able to build our smart contract. Let's see what happens. There was an error. So type I32 is not assignable to type. Okay, let's see. So this guy is saying that the amount should be of type U right here, of type U128. And for us to do this, we can do U128 dot from U64. Awesome. That should be able to do the magic. Let's try this again and see what happens. Let me just clear the terminal. I really hope this works this time around. Otherwise, it will really have delayed us. Come on. Okay. Let me hope that's going to be successful. It has really taken long. Awesome. So that was really successful. If we go back to our IDE, we realize that there's this folder that has been created with the file, the WebAssembly byte coordinate. So that is what we're going to deploy. So I'm basically going to run my deploy script. Key not found, that was expected. Then it's going to create the account and save the credentials and deploy, and that was done. So we can clear that out. Then we basically are going to call, we're going to call the method. In this case, we're going to do near, should be a view, but let's do call, near call. In this case, we're going to call a smart contract, or rather invoke a smart contract function that was deployed under this ID wallet address. And the method name in this case is that what I just copied. I really can't read that. Does it require any argument? No, so it doesn't require any argument, so we can just do empty. Then the account that is going to sign this particular transaction will be provided as SA cohort 2. Now this can be any account, any testnet wallet address, or mainnet if you're mainnet, that is basically going to sign this particular transaction. So I'm also going to call this, and let's see what response. Now in this case, since this method is going to call this function in the smart contract we deployed for Rust, then we expect the response to be hello world from Rust smart contract, not from these because this method is not within our smart contract anyway. So let's see what that gives us. Call. Fingers crossed. Did I attach enough gas? Let's see. Let's see. Awesome. So that just worked. So you realize hello world from Rust smart contract string was returned to us. So in this case, this method was not within our smart contract. It has been called from the Rust smart contract we just deployed. Okay, guys. So that is how you do a cross-contract call from in assembly script smart contract. So that is how you basically implement it. Time is not on our side. I'd really be talking about, I wish we had time. If you guys can allow me, maybe we'll be talking about callback functions. So in this case, okay, that string was returned to us from the terminal. But what if we wanted to utilize that particular feedback from that function within our smart contract to sort of do some other actions with it? So for now, you'll just allow me stop at that point. Then I'm going to create another function right here within our assembly script smart contract now. I'm going to call it hello world. Now, in this case, you realize that the naming is different with that, okay? Just to bring in some differences. So this smart contract will be returning a string. And in this case, we also need to return, let's do hello world from assembly script smart contract. Awesome. This should return. Okay, awesome. So this should return hello world from assembly script smart contract string. If we did this right. So I'll just deploy this and test it first before we can call it from our Rust smart contract, okay? So I'll just go ahead and build that first. This building really takes long. Okay. Let's really hope this goes successfully. So we're basically going to deploy this smart contract with our hello world function. Then we're going to test if we can run it from our terminal first. Awesome. So that was successful. And after that, I'm basically going to deploy. I'm going to deploy that WebAssembly file to blockchain. This is basically updating our smart contract on blockchain, guys. So we need to update that. Maybe as that updates, I'm going to change this the command within the call script. So in this case, I'm going to comment that out. Then I'm going to call hello world function that we just added within our smart contract. In this case, it's a view function. So this was done deploying successfully. I'll just clear that out. Then let's call our hello world function. Awesome. So you realize that from the assembly script smart contract, this is the string that is being returned to us, hello world from assembly script. Now we basically want to get this particular string from our Rust smart contract. Okay. So let me switch back to the Rust project right here. Then we're going to do this from this point as well. Now, Rust is a bit complicated. So guys, this will really need your attention. So like I was saying, we first need to, there's a macro that has been availed to us. Moses, you want to say something? Yes, you can go ahead and talk, Moses. Just unmute and raise your concern.
I was requesting after the lesson, you could maybe give me maybe 10 minutes or 20 minutes of your time.
Okay.
Okay.
Awesome. So first of all, we're going to define a trait. Now, for us developers, you know what this means. We're going to define a public trait that is basically going to sort of help us encapsulate how the function looks like in the assembly script smart contract. Okay. So in this case, we're going to call it external contract. Okay. And our external contract has a function by the name hello world that we want to invoke. In this case, it's not accepting any argument. So the only one we can give it is that. However, we expect it to return a string. Okay. So if you've worked before with what do you call it? The other programming languages, you know how to create an interface. Okay. So a trait is basically sort of an interface in the other programming languages. Now we need to use sort of some macro up here. Call it external contract. Don't know if that will help us do the magic. Let's call it contract DB. So this should be able to, okay. I think I missed something right here. Come on. Yeah, that fixed it. So we are also now, my IDE is complaining with the my naming convention, but then this is how the method looks like in the contract we want to call it. So let us see if that if this guy will allow us just go with it as it is. Now, coming back to our contract, now here is where we're going to implement the Rust function that is going to do the cross contract call to the assembly script smart contract. I'm going to name this function, let's give it a name XCC AS, okay? Then do the due diligence to Rust. Then you basically can return void. So we're returning basically nothing right there. Well, let's return a promise. Yeah, we should return a promise in this case. Awesome. So the promise we're going to return is formulated as follows. Now, once this file has been built, this trait is going to be converted to a module within the Rust programming language, within our project in Rust, that is. So this module is basically going to have a name, contract B, and it is going to contain a function called hello world. Now, to structure our cross-contract call, we're going to use this particular module, contract B, right here, that. Then from it, we're going to invoke a function by the name hello world, like that. Then right from there, we need to specify what? The address of the contract we are calling. So in this case, I'll just give it, let me just do this right here. So this is basically going to help us return the address in Rust. So the address that we're going to perform this function on is right here. So I'm just going to copy it from this point, then come back right here, and let's paste it over here to stream. Awesome. So that should be able to help us get the address. So in this case, I'm simply going to do self cross contract call address. Then after that, I need to provide the name of the the name of the function that is there already. So if I had any arguments to the function, that is what would go next. But in this case, I don't have any. So I'm just going to proceed with should proceed with gas. Hope I'm not wrong on this. So we need to create some constants just like we did in our assembly script project, the constants that are going to help us do this. So maybe I can just copy this from here and bring them over here and make the changes that are needed. So we're going to have a const of gas. So that should be that deposit. Now that is how we represent that value in Rust. Then this one should be 0. Then we already have this, so we don't need that really. This is of type gas, and this is of type, should be of type balance, right? Then we need to import these types somewhere, just so that our IDE don't swallow us. Stop complaining. Awesome. So that is basically how we do that. Then we come down here and provide the gas, then provide the deposit. In this case, we're not giving a deposit. I don't know why they're complaining this much. Expected that, but then found that in here. Then in this case, you can just change this to U64. Then right here, we can change this to U128. Okay. Awesome. Now, from there, we have all that. That should be able to go. Cannot find type promise in this scope. Maybe I'll need to bring this in as well. We're not using balance, so we can just take it off. Awesome. So let's deploy these particular smart contracts and see what is really going to happen after. I mean, when we call this function the cross contract caller S, so we expect it to call the hello world. I'm really going to have an issue with this, but okay. Let's see what that is going to do. So I'll switch back to the Rust terminal window. Maybe just clear all that out, then build. So let's build, come on. Let's build this first. And see what that brings on board. It was done. Okay, let's deploy. Then after deploying, I should be able to call. Now let me just change this function in our call very fast. So right here, we are saying call cross contract AS function. And in this case, we're going to do a call. Doesn't require any parameters, so we're going to provide the account ID that is going to sign this transaction as cohort2.testnet. Awesome. Then, yeah, we should be able to call our function. So let's see what that brings on board. So that was done, deploying successfully. Let's try calling this and see what happens. Okay, so this guy is saying that where's the error? Or is the error here? Action error. So I really think Rust misinterpreted our function naming. So I'll just change this back. Just allow me, guys, change this back to hello world, because Rust doesn't allow the camel case sort of naming convention. So I'll just change this to hello world and maybe add these as AS, hello world AS. Then I'll just go ahead and deploy this over here, build. So after building, you should be able to deploy. Then let me make the change as well from a Rust smart contract. So right here, I'll just copy it as it is. Then I'll just paste it right here, like that. Awesome. Great. So these should be able to work now. Okay. So let's see, that was done building. So let's deploy this. Then move to Rust, just clear this out. And right here. So we changed the function. Where's that? Change the function right here to hello world s, and we made the change as well down here. And let me just cheat and see if there's anything I'm getting wrong. So where's that? So was that done deploying? Yeah, so that was done deploying. Great. So what else do we need? So okay. So right here, I think with this, the deposit comes first, then the gas. Maybe that we made a mistake right there. So these expect U128. Then our gas U128. Okay, so we're basically going to deploy that with the changes we've made and see what that is basically going to give us. Let's see what that is going to give us. So I'll just go ahead and build these guys. So it was done. Okay, just some warnings, you can use imports, but we'll ignore that for now. So I'll just go ahead and deploy. So let's hope this deploys as fast as possible. I'm really sorry for eating into your time, but let's see if this is going to work from Rust. Then maybe you can call it a night. Then I'll find time so that I explain more on the callback functions. That is how you can handle the feedback, whatever that is being returned by the functions you're calling from other contracts within your smart contract, that is. So that was done deploying. Let me go ahead and test if this is gonna call successfully. So I hope my call was done well. Okay. Awesome. So that just worked, guys. So it returned hello world from assembly script smart contract. So this is what that is from the function we called on our Rust smart contract. So this is the response that we got. And remember, this response is from our assembly script smart contract. So it's from a different smart contract. Okay. Yeah. So this is basically how we do it. That is basically simply how we do it. But as we start handling the callbacks of what the functions return within our smart contract, things get a bit complex, but you don't have to worry about that. I'll be explaining how all that can be achieved and how all that can be done. So I guess we should stop at that point. I'll invite you guys for another session just to explain more on the callback functions. So I don't know if is there any question up to that point? Any question or anyone who needs any clarity? Now, have you guys understood what the cross contract calls mean or how to go about them in your development, in your smart contract development? Bridget? Bridget, hello.
Hello.
Hi.
Hi.
Have you got something from today's session?
Not really understood much, but I'll go through the recording.
Okay. Okay. My brother Obi. Obi, have you got something?
No question, no question.
No question. But have you got the concept?
Yeah, I understand the idea, but I'll still have to like look back at it since I'm not really familiar with Rust. So some
Okay.
things are quite, yeah, but I get the idea.
Okay, awesome. Actually, you're inquiring about the fungible token and the NFTs.
Yes, exactly.
Yeah.
Yes.
So you'll really need to be able to understand this before we can move there, because this concept is really at the center of those are the concepts that we're going to look at in our coming sessions.
Okay. And that link you sent, that's what we can use to like read further, right?
Yeah, that link explains the standards that are going to be like what you should know before you come to the session. Sort of, you should be able to understand the standards that a smart contract needs to have before you even write any smart contract dealing with fungible or non-fungible tokens. So it's like you want to put up a house, but then there are standards within that particular area of that nation that is required of that particular house. So the height and all that and all that. So these are standards that have been arrived at by other blockchain networks as well, the likes of Ethereum, Solana, and all that. So it basically brings an interface where smart contract or fungible token smart contracts can be able to interact with other smart contracts from other blockchains. Yeah, so that's why you really be required to sort of go through that and understand and know what is expected of your fungible token and NFT smart contracts. Then we'll be reading into that.
Okay, cool.
Okay. Now, guys, if you want to get some explanation on smart contract, maybe I don't know if I can open this tab. Oh my God. Okay. Awesome. It just opened. So if you need to find further clarification or explanation on the same concept, I'll just direct you to our resource. I think I shared this link with you before, or maybe I can just do it for the sake of those of us who may not be having it. It's in the chat. So this is going to load the page right here. Then you're going to scroll down, choose your path, near certified developer course. And this should really bring up all the resources within the NCD course, basically. Okay. So I know it's taking long to load. Okay. So right here, there's a section. Okay, the resources, the tools. Yeah. Let me go with the assembly script. So there's this link right here, cross contract calls. If you just click it, should be able to redirect you to a tab. And this tab is basically going to display a web page that is talking about cross-contract calls. So you can read through all this theory, then embark on this recording and basically follow through and see how things are unfolding. That way you'll be able to understand this concept even further. I'll be frank with you, getting this concept at first for me was quite hectic. I really faced some bugs and I was almost giving up on this. I was really giving up on this because I think I should just show you this right here, guys. Now, if you're doing a cross-contract call, but then you are unable to specify the right amount of gas, you realize in this case, we have a constant up here stipulating the cost of gas we need to spend for this particular smart contract. Now, if you're going to wrongly do this, then trust you me, you'll say blockchain development is almost, it's difficult, but it's not. So really check on this while you're going to work on this on your own, even as you follow up with the recording. Really check your gas, whatever you're going to allocate for your gas fee. If let's say I did something less than what is required, okay? Like we can do something less than what is required. You can just try it on your own and provide the gas that is less than what is required of you. It is going to raise some very rude errors. So that is where, that is what I realized after doing like 3 days of debugging. So that is what at last I came to realize. So thank you guys for coming. I'm really hoping there's no other question. So up to that point, I'll just appreciate us for coming. And yeah, I can see someone wants to talk. Moses, yes, you can just go ahead. Moses?
I was just reminding you of the timing
Okay.
that I had earlier requested.
Okay. Thank you. So Cynthia, I don't know if you are able to greet us and tell us something maybe. Cynthia.
Hi, everyone.
Hi.
I hope you've learned something. Thank you so much for joining us. Yeah, that's all, Paul. I don't have so much to say.